Hi and welcome back to the second part of the video about how to use Ettercap in combination with the GRE-Relay plugin. So maybe if you haven't seen the first part of the video, so I recommend doing this to get all the theory part before. But a little recall on the topology that we have lined out in the presentation before. We have on the left side the victim with its public IP, not its private, its public IP in the internet 198.51.100.1. We have on the right side the target, let's say the destination server with its IP 203.0.113.1. And somewhere in the internet we have a attacker machine with its internet IP 192.0.2.1. And what we are going to achieve with our demo is to redirect the traffic from the victim towards the server over the attacker, so that we can see the traffic and maybe do something with it. Yeah, so let's have a look at how this is being realized in the lab. The lab been done via GNS3 as the router virtualization. So let's quickly run over it. Our victim in the private network doesn't matter because it's been nutted to an outside IP, which is then internet routable, and this is the only IP that we will see in the internet. So we don't care about what's within the private network. Router 2 is a simple transit ISP router, nothing special. On this router 3, this is now our key router because this is the one that we have gotten under our control over certain circumstances, I would say. And in router 4, still within the ISP network, that is, let's say, building the bridge towards the rest of the internet. And in the internet, you have to imagine that somewhere there is the web server, the destination server connected, and also our attacker machine. Okay, have a little look at the machines involved. Here we have our client machine, our victim, running in a Debian with the graphic user interface GNOME desktop. So let's see if we can reach our web server, our target. So 113.1, I think was IP. Yes. Okay, so we can reach the web server, and yeah, so let's see if we can also reach it via the web page. I can load the web page. Yeah, so here it's just a default web page that comes with the Apache installation. So both works. One word on the on the latency. So what we can see is that we have a latency currently, without being redirected, between victim and the destination about 70, 78, 75, I don't know, milliseconds. Just keep this in mind. We will get back to it later. And then now we switch over to the attacker machine over here. So it's basically also in a Debian system, just installed with a different graphic user interface to better distinguish between both. On the attacker machine, I also want to leave a word on the IP address, because when you have a look at the IP address, it's different than what we have seen in the presentation. Quickly go over it. Come on. In the presentation, we've mentioned the .1 address at the end, and it's configured with a .2, so different. But this has really a reason behind, because the actual IP of the machine itself has to be different than the one that is used by the GRE-Relay plugin to terminate the GRE traffic. So you have really to have a free IP in your attacker subnet that you can, let's say, borrow for the GRE-Relay plugin. Okay, but that's it on that side. The third machine involved is the web server. It's a FreeBSD machine just hosting this default website from Apache, so really nothing special there. Okay, so I would say let's start. Let's start with starting Ettercap on the attacker machine as a first step. I'm starting it with a graphical user interface. Start unified sniffing. And yeah, the first thing we have to do is we have to go to the plugins list. And if you don't know which IP you can use the Find IP plugin. Just double click and it will show you which IP is the next free which can be used, and in our case it's really the one that we are aiming for, that we can use though. Okay, so next thing would be to start the GRE-Relay plugin. It's down here. And when you start it, it will ask you now for this unused IP I've mentioned earlier. And so we will input here now our, what was it, 2.1 IP address that we want to use to terminate the GRE traffic. Say OK, and let's say we are ready from the Ettercap side. Now it's just running on an Ettercap machine, but the traffic is not reaching it. So for that we have to take care and now have to modify the configuration of this point router yeah, to really redirect the traffic. So open the console to the router. Come on. Okay, here we go. So I hope this is somewhat readable. Let's make it a little bit bigger. Okay. Okay, here we go. I think now it's readable. Okay, so did look at the interfaces. So we have 3 interfaces, 2 physical ones, one which is towards the victim machine, and the other one, the FA0/1, is towards the internet. Okay, so the first thing we have to do is we have to create now the tunnel interface. And for that we created just with the tunnel 1. And we give it an IP address, and with this IP address I'm choosing something that is not routable in the internet. I'm choosing the address space IP bar, however it can be anything effectively, it doesn't matter at all. Okay, and then some little tunnel statements, because we have at least to define the tunnel source IP. For the tunnel source, I'm choosing the IP address of the interface pointing towards the internet, because in this direction the tunnel is going to. However, we can choose any other that is routable, of course, as a source address. So FA0.1. And we have a tunnel destination, which is the IP address now of our attacker machine, and specifically the IP address that the GRE-Relay plugin is listening for. And that's it for the tunnel, and we can directly see that the tunnel interface went up because we don't have to define anything else, because everything else defaults to gray anyway. So now we have defined the tunnel interface. So far so good. The next thing was that we have to create an IP address access list to describe the interesting traffic. So an access list called interesting. So typos you can you can take on your own. I take mine. So permit IP host. So here we describe with permit what the packet should look like, that it's interesting for this access list here. In this case, the source IP should be the public IP of the CPE router. So 198.51.100.1, and the destination IP was our web server with the 203.0.113.1. So now we describe what we are interested in. Now we have to set up a route map. We call it detour, and within its sequence number 10, we now refer to our access list we just created. Interesting. And when this is the case, when this is matched, then we are setting and overriding the next hop to an IP that lies within the subnet of the tunnel we've just created. So effectively this one .2. Something else. Okay. So this is a forward path. So go to the little diagram here. So now we described on this router that we are interested in packets that come from the victim towards the destination server, and we override the next hop pointing to an IP address lying within the gray tunnel. So that's been effectively forwarded to it. The next thing would be that we also do the same for the reverse traffic. We will create another IP address access list for that. We call it interesting reverse. And it's really the reverse description of the IP addresses here. Everything that comes from the web server and goes to our victim, public IP, of course, we are interested in. And we create another route map sequence number, effectively, so use the same route map. We match our newly created access list. Interesting reverse. And we do the same, we set the next hop to any IP within the subnet of the tunnel. Okay, so far so good. So what we've done, we have created a tunnel interface, type of gray, set it to point to our public IP of Ettercap machine. We've described what we are interested in, and when this is really the case and it's matched, then we override the next hop towards anything into the tunnel. What we've to be done now is really to bind this route map to the physical interfaces of this router. So on both sides, because we're interested in the forward and reverse traffic. So we go to FA00 and we bind it with the statement IP policy route map detour on this interface. And the same we are doing on the other interface. Same statement, policy route map detour. Okay, and we are done for the part of to be done on the router. Let's go back to our virtual machines. So our victim. So let's see if we can still reach our destination host, because we want to maintain the connectivity and not disrupt it. So ping it again, and hopefully, yeah. So there comes the reply. And so now I'm coming back to the latency I've just mentioned before. You can see that more or less the latency more or less doubled. So effectively it increased, which is an indicator that really the traffic is now taking the extra path between victim server and the attacker. So all the latency adds up, and this is really something that can be observed. Let's see if we can still load our web page. Yes, so this succeeded. We have still access to our web server, so the victim itself, despite the increased latency, should not have noticed anything that we are now in between. And now have a look from the Ettercap perspective. So the easiest way would be to go into the connections table, and here we see directly that we see from the victim side to the destination, we see the connection with transceive and receive bytes. So we have bidirectional traffic going over our attacker machine, and so it's effectively working. However, for me, it's not really representative enough, because let's try to really modify now the contents of this web page when it's been transferred to really show that we are really in the path and we have really redirected traffic and are man in the middle. So a little detailed look at what is going on the HTTP layer, because the client indicates here that it has already fetched the content already sometime in the past. And so the web server answers not with the actual content, but just with the kind of yeah, please use your local cache. So we have to take care of that to effectively replace the content. We have to motivate the web server to retransfer the content so that we have a chance to also modify it. For that, I've prepared a little filter. So have a look at that. I think it's HTTP replace.2 ECF. And here the filter, it's consisting of two parts. The first part is when the TCP port is 80, which is the case when we're going from the client towards the web server, so the request effectively. And then we are looking for if we see some header lines with the if modified since. And the simple thing that we are doing is we're replacing with something else, yeah, that is making it invalid, so that the web server hopefully is really thinking we don't have a local cache for that. Please transfer the actual content. So that's the first thing to trick the caching. And the second thing is the actual replacement. So when the source port is 80, which is the case for the reply of the web server back to the client. So here we look just simply for the it works and we replace it with it rocks, and we just place a message in the message pane. So compile this filter and load it into Ettercap. I'm putting the output file in temp because Ettercap is running in unprivileged mode. Therefore, we have to put the files it has to read in something that it's allowed to read into access. So I go to temp because everybody has access there. HTTP replace.ef, and the source file was HTTP replace to ECF. Okay, that seemed to be working. Now loading this filter in Ettercap, which we are already running. Go to temp. Here we go. And okay. Okay, so filter is running. And now we are just reloading our web page and see if it's working. And yes, so that's good. That simulation demo is really doing what's supposed to be. Now it's showing it rocks. So that means that we have really our man in the middle. We are not in either the client network or in the destination. We are somewhere in the internet. We redirected the traffic using GRE to our Ettercap machine. And we really replaced now content. So let's have a look at the connection. Here we go. Here we see the actual content in the payload, which we had the filter had then the chance to replace it. Yeah, so that's more or less the demo and this video, the content of the video. I have to leave one little word on kind of a disclaimer. So everything what you see here is being done under my own control. So if you're doing something similar, you have really to have the explicit permission to do that. Otherwise, it's illegal. The purpose of this video is more for educational purpose. And yeah, so I hope that you will come around soon and watch out for new videos coming in the next weeks. I'm planning to bring up more, especially for the upcoming version of Ettercap. There are really new and cool stuff I want to highlight. But that's it for now, and I think there's nothing left to say other than say thank you for watching. Come around soon, and take care, and bye.